By now we have a good idea of what logarithms are. They are nothing else than numbers. And a logarithm of a specific number is nothing else than the exponent of the power of the base that is equal to the specific number that we're trying to calculate. So, just for a review, just to look at this number, at a logarithm together, what we are going to review right here is the log with base 2 of 16. Very simple one. 16 is a perfect power of 2. It is 2 to the 4th, so the log with base 2 of 16 is nothing else than the log of 2 to the 4th. Okay, so now easily we can see that the exponent, where we raise the base 2 in order to get the number 16, is the number 4. So that's the logarithm. Okay, good. Now, what we are going to do is we will look at the logarithms a little bit more closer, and we will realize that as every other operation and function, they have some peculiar properties that it would be great if we try to remember. So I have them right here for you, the main properties that you need to remember for the logarithms in general. And of course I want to remind you that the log of 1, no matter what the base is always 0, and that the log of the base itself is nothing else than 1. So if you try to memorize those 7 properties, then you will be able to handle and solve many problems, to calculate logarithms easily, to combine logarithms together. But let's see first of all, when we multiply like bases, and we can see that right here, then basically what we do is that we add the logarithms. So when we multiply bases, we add the logarithms. Okay, and why is that? Definitely there is a reason. So let's say together, let's assume that you want to multiply the log with base 4, let's say 2, with base 2 of 4 times 8. So let's see that. First of all, 4 times 8 is nothing else than 32. So it's 4 times 8 is the number 32. So basically, the logarithm of 32 can be split, if you want, to log of 4 times 8. Okay, so what do I have here? I have a product. Perfect. Now, what is 4? Well, 4 is the log with base 2 of 2 squared. And what is 8? Well, 2 to the 3rd. So basically what I have is log with base 2 of 2 squared times 2 to the 3rd. Now, if you look at the 32 itself, this is nothing else than the 2 to the 5th. Okay, perfect. So what do we have? On the one side, we have the following. We have the log of 2 to the 5th, where the exponent is 5, so definitely, as we already know, this is nothing else than 5. On the other side, right here, we have that this is, through those steps, equal to the log with base 2 of 2 squared times 2 to the 3rd. Well, what this rule that we observe tells us is that we can split the logs. And this is going to be equal to the log of 2 plus the log of 2 squared plus the log with base 2 of 2 to the 3rd. This is what the property says. Well, let's see, is that true? Well, the log of 2 squared is going to be equal to 2. The log of 2 to the 3rd is going to be equal to 3. So this is going to be equal to 2 plus 3. That is equal to 5. Well, what do we have? If we take the log of 32 as 2 to the 5th, then we come up with the answer 5. If we take the log of 32, we split it, and we see it as a product of these two powers, then again the result is 5. So this by itself tells us that the property works. It holds. So whenever we multiply like bases, logarithms of like bases, then we add the exponents to get the answer. This is what this property tells us. On the other side, we have another property that says if we divide now like bases, we subtract the exponents. Basically what we do is that we take the exponent of the numerator and we subtract the exponent of the denominator. Okay, let's see. Log with base 2 of 2 to the 5th divided by 2 to the 3rd. Let's look at this. Okay, this is nothing else than log with base 2 of 32 divided by 8. 32 divided by 8 is nothing else than 4. So what I have basically is log with base 2 of 4. But this is the log with base 2 of 2 squared. So this is equal to the exponent and this is equal to the number 2. Excellent. Now what I want to do is to simplify the fraction. 2 to the 5th divided by 2 to the 3rd is, what the rule tells me right here is that I can subtract the logarithms. So it tells me that this logarithm over here with base 2 of 2 to the 5th divided by 2 to the 3rd is equal to the log with base 2 of 2 to the 5th minus the log with base 2 of 2 to the 3rd. Let's see if this is true, if this is holds. And the truth is that it holds. Right here, if you look at this logarithm, this is going to be equal to 5. And if you look at this logarithm, the exponent is 3, so it is equal to 3. So what I do is I subtract 3 from 5, and the result is 2 again. So the property holds. And this is how we come up with this generalized property that it tells us that whenever you divide bases, when you divide two numbers and you get the logarithm of the two numbers, then this is equal to subtract the exponents. Now the third property says that when we raise to a power, then what we actually do is that we bring the exponent down and we multiply it by the logarithm. With few words, let's look at an example. If I have log with base 2 of 2 to the 5th, then I can bring the exponent down, and this is going to be 5 times log with base 2 of 2. This is a property. This is what the property says. And this is equal to 5 times, well, this is equal to 1. 5 times 1. And this is equal to 5. So all the properties that we have here hold. And I can use each one of them. We will see separately this property right here, and we are going to work different problems with this. Every time that we will work a problem, I'm going to share this table with you in order to make sure that you know that you know what to use until you memorize the table.